Alright class, we're going to start lesson 8.8 here today, and this is going to be on solving quadratic equations when our a does not equal 1. So in the past couple of lessons, we've been primarily focused on when our a is 1. So for instance, x squared plus 3x plus 10. So your a is 1. Well, that's not going to be the case in the problems that we're going to be doing today. Your a is going to be something other than 1. And the process that we're going to use to solve such equations is going to be essentially the same. Alright, so we're not going to change a whole lot, so this should be a relatively smooth lesson. Alright, so in example 1 we have to solve 5x squared plus 11x plus 2 equaling 0. And then step 1, like it has been in the past, we're going to find factors of a times c that sum to b. So we're going to write down what our a is, we're going to write down what our b is, and we're going to write down what our c is. So our a is 5, our b is 11, and our c is 2. Alright, so factors of a times c. So a times c, so factors of 10, because 5 times 2 is 10, that's sum to 11. So the factors of 10 are 1 and 10, and 2 and 5. So which combination there is going to sum to 11? It's going to be this first pair right here. Alright, and so that's step 1. Alright, the next step is to write those factors as fractions over our a term. Reduce if possible, but keep it written as a fraction. And then in bold there, if a is negative, keep the negative sign with the number in the denominator. Alright, so our factors we said were 1 and 10, and so we're going to write those over our a term. So our a term is 5, so we're going to have 1 over 5 and 10 over 5. Alright, so this is nothing different than what we did in the past, but remember in the past our a was 1, so we would be dividing by 1. Well, that's not the case here. We're going to be dividing by whatever our a is. Now it says to reduce if possible, but keep it written as a fraction. Alright, so we are good here, but 10 over 5, that's going to equal 2 over 1. So it's important to reduce, but keep it as a fraction. Alright, and so there's really the only difference. We're putting our factors over our a. So now everything else is as normal. So you take that 5 right there, and you're going to pair it with an x. Alright, so we're at step 3 right now. So we're going to have 5x and then plus 1. Alright, so the plus 1 there. And then over here we have the 1, so pair that with an x. So 1x, or just x, and then plus 2. Alright, and so right now we have the equation written in factored form, and we're ready to go to step 4. So in step 4 we want to set both factors equal to 0 and solve. So we're going to have 5x plus 1, set that equal to 0, and then set the x plus 2 equal to 0. We're going to subtract 1 from both sides. So we have 5x equaling negative 1. Divide by 5. So we have x equaling negative 1/5. Alright, there's one of our solutions. And then the other solution, subtract 2 from both sides, so we have x equaling negative 2. Alright, so those are our solutions, and then that's our factored form. Okay, in example 2, we want to solve negative 4r squared equaling negative 54 minus 6r. So what you notice here that this equation is not written in standard form, so we have to put it in standard form. So we're going to get everything on one hand side of the equal sign. So I could move the negative 4r squared to the right, but I would just want to deal with one where your a happens to be negative, and how you would handle that. So let's first start by adding 54 to both sides. So you would get negative 4r squared plus 54 equaling negative 6r. And now let's add 6r to both sides. So we're going to get negative 4r squared plus 6r plus 54 equals 0. If I were to do this problem, I probably would move that. All you would have to do is just move that over to the right, and your a would be positive. But again, I want to show an example where your a is negative and how to handle it. Alright, so our a is equal to negative 4, our b is equal to 6, our c is equal to 54. Alright, so we're looking for factors of a times c that sum to b. So a times c, so we have negative 4 times 54. That's going to give us negative 216, and it has to sum to 6. Alright, so the factors of negative 216, or the factors of 216, there's a lot of them. Alright, there's 1 and 216, there's 2 and 108, there's 3 and 72, 4 and 54, 6 and 36, 8 and 27, 9 and 24, 12 and 18. And I'm going to stop. So right there I noticed I have a difference of 6 here. So I have to have, my factors have to multiply together to get negative 216. So one has to be positive, one has to be negative, and then they have to sum. When you add them together, they got to sum to 6. So I'm going to make the 12 negative. Alright, so there's my two factors, negative 12 and 18. Alright, so because, so now what do you do with those? You take the negative 12 and you take the 18 and you write it over your a. So negative 4. Alright. Now, your a, if it's negative, you always put the negative in the denominator. So let's just say that my, so like right here, the 18 over 4. Notice how I attached the negative with the 4 and not the 18. Alright, so that's super important, and that's why it's bolded up in the previous example, in the steps. Okay, so now we want to reduce to a fraction if we can. So negative 12 divided by negative 4, that is a positive 3 over 1. And then 18 over negative 4, I can divide top and bottom by 2 to get 9 over negative 2. Again, I keep that negative in the denominator there. Alright, so now I can put it in factored form. So that 1 right there gets paired with an x, and then plus 3. And then we have this negative 2 gets paired with an x, so negative 2x, and then plus that 9 equals 0. Alright, now we want to set both of those factors equal to 0 and solve. So x plus 3 equals 0. Subtract 3 from both sides. So x equals negative 3. There's one solution. And then I'm going to go upstairs here. Oops. Oh boy. What'd I do? Alright, I got it back. So where were we? Okay, so the negative 2x plus 9. So we got to set that equal to 0. Negative 2x plus 9 equals 0. So we're going to subtract 9 from both sides. It's getting messy here. So we have, let's use negative 2x equals negative 9. Divide by negative 2. Divide by negative 2. And so x is going to equal negative 9 over a negative 2 is a positive 9 halves. Alright, so we got it into that slide. So there's your two solutions for that one. Alright, there's two more examples left. I want you to try those on your own. Go ahead and hit pause, and then when you're ready, I'm going to write down what the correct answers are so you can check your work. Alright, so for example 3, the solutions are x equaling negative 1/2 and x equaling 7. And then for example 4, x equaling negative 3 and x equaling 13 thirds. Alright, so this wraps it up, and as you can see, we didn't change a whole lot when our a did not equal 1, just made one minor little tweak, and everything else stayed the same. So hopefully you guys found that to be relatively easy today.